Welcome to this explainer. Today, we're diving straight into Chapter 2 of the Cambridge Handbook of Behavioral Data Science. Now, you might be wondering, why does this specific chapter actually matter to us? Well, think about it. We live in a world where literally every click, every swipe, your financial transactions, even your morning commute, they all leave a massive digital trace. Making sense of all that data to actually understand human decision-making, that requires a totally new scientific approach. And that's exactly what this chapter breaks down, what this new approach is, why it's absolutely necessary, and how it's actively reshaping the world around us.
To really grasp the central problem this chapter tackles, we kind of have to look back at how we got here. Human civilization has powered through 4 major industrial revolutions, right? We moved from mechanization in the 1760s to electrification, then automation and digitization in the 70s, and most recently, the explosion of machine intelligence in the 2010s. But here's the catch. The central challenge we're facing right now is that we are navigating a post-4.0 era. This is the era of collaborative intelligence. It's a stage where progress isn't just about raw computational power anymore. It's about how humans and intelligent machines meaningfully interact and collaborate. The sheer volume and velocity of digital data generated today is mind-boggling, and it simply cannot be handled by our old scientific methodologies.
And that brings us to the main argument of the chapter. Historically, traditional behavioral sciences like psychology or experimental economics have relied pretty heavily on small-scale, self-reported data, the kind of stuff gathered in highly constrained laboratory settings. Now, while that's incredibly valuable, let's be honest, what people say they do in a survey often looks very different from what they actually do in real life. Behavioral data science, on the flip side, leans into naturalistic, high-velocity data. It studies behavior completely organically, right where it happens, in these expansive, data-rich digital ecosystems. Section 1. The core concept. Behavior is data-rich. The absolute crucial point to take away here is that behavioral data science offers a complementary paradigm. It isn't trying to completely replace traditional psychology, not at all. Instead, it shifts our focus to what people demonstrably do in real-world settings. By capturing these time-stamped sequences of human actions, from, say, your keystrokes to your daily commuting patterns, researchers can analyze actual lived experiences. We can finally see how habits form, how decisions completely change under time pressure, and how people act when they aren't just filling out a questionnaire.
The whole field is essentially structured into 3 foundational interlinked strands: human, algorithmic, and systems behavior. Let's break each of these down because understanding this framework is absolutely core to the entire chapter.
First up, we have the human behavior strand. Now, this is probably the most traditional objective, trying to understand and predict what individuals and groups will actually do. But the game changer here is that it's powered by massive data sets. A really concrete example the chapter gives is the use of passively collected mobile phone GPS traces. Researchers can actually couple these behavioral signals with environmental variables, like the weather or economic indicators, to predict urban physical activity patterns, sleep rhythms, and even population-level mental health trends. It's fascinating stuff. Next is the algorithmic behavior strand, and this represents a massive methodological shift. Instead of just studying humans, we're actually treating algorithms themselves as behavioral entities. Think about it. Algorithms, like the recommender engines on your favorite streaming platform or the navigation software in autonomous vehicles, they receive inputs, produce outputs, and adapt over time. They behave. So we have to study their behavior to ensure they perform reliably, that they remain fair, and crucially, that they don't inadvertently amplify existing societal inequalities. And the third strand is systems behavior. This is where we zoom out to look at the whole picture, the complex adaptive systems where both human and machine agents are collaborating and interacting. A prime example here is the use of digital twins, which are real-time virtual replicas of physical systems. By feeding live sensor data into a digital twin of, say, an agricultural network or a city's transport grid, we can mathematically model how those micro-level behaviors from humans and algorithms combine to create massive macro-level outcomes.
Section 2. Real-world systems and applications.
You can really see how these 3 strands coalesce when you look at a smart mobility system. Here's how it works in practice. First, individual commuter choices are logged, so that's your human behavior. Next, predictive algorithms crunch that data to recommend new, highly efficient routes. That's the algorithmic behavior. And finally, all of these intertwined actions scale up to impact citywide traffic congestion and carbon emissions. And that right there is systems behavior. It is a continuous, multi-level feedback loop.
And these applications are advancing rapidly, especially into generative artificial intelligence. The chapter highlights a really interesting connection to behavioral AI, using large language models, or LLMs, as simulated agents. What researchers are doing is prompting these models with moral dilemmas or economic games to essentially prototype behavioral interventions in silico before ever testing them on actual humans. It offers a highly scalable way to test social dynamics. But the text definitely warns that this requires strict methodological humility. Why? Because these models can sometimes just reflect their training data patterns rather than representing genuine human cognition.
Section 3. Navigating limitations and tensions. As you can imagine, this field carries some pretty heavy structural and ethical responsibilities. First up, there's the challenge of behavioral feedback loops. Algorithms recommend content, which changes our behavior, which the algorithm then measures all over again. This creates a huge risk of echo chambers and behavioral lock-in. Second is embedded bias. Datasets absorb historical societal inequalities, meaning there is a very genuine risk of misclassification or exclusion for certain marginalized groups if things aren't carefully managed. And third, interpretability. As these models grow more complex, they can become opaque black boxes. Think about it. If an institution uses a behavioral model to flag a student at risk of dropping out, we absolutely must be able to explain why the model made that choice in order to offer any meaningful help.
So what does this all mean for organizational leaders, AI practitioners, or policymakers? Well, the chapter lays out some essential lessons. First, you have to avoid over-relying on coarse data without context. I mean, a GPS ping doesn't tell you why someone went to a specific location. You also need to distinguish between a predictive pattern and a causal driver. Predicting that an employee is going to quit is definitely not the same as understanding why they're unhappy in the first place. On top of that, remember that a model trained on one demographic won't necessarily transfer to another culture. But the biggest takeaway? Technical excellence absolutely must be paired with transparent data governance and procedural fairness. Always.
Which really just leaves us with this provocative thought. As we officially enter this era of collaborative intelligence, who is going to shape the algorithms that shape our behavior? Behavioral data science is finally giving us the tools to deeply understand this entangled digital world we live in, but it demands critical reflexivity from every single one of us. I strongly encourage you to read the full Chapter 2 in the Cambridge Handbook of Behavioral Data Science to explore these vital concepts for yourself. Thank you so much for joining me for this explainer, and as always, keep learning.